Have you ever wondered how diesel engines, despite their efficiency and durability, manage to stay environmentally friendly? Well, today's your lucky day because we're diving into the world of diesel particulate filters, or DPFs, and how they help keep our air cleaner. So, what exactly is a diesel particulate filter? Simply put, it's a device designed to remove soot from the exhaust gas of a diesel engine. Diesel particulate matter resulting from the incomplete combustion of diesel fuel produces soot, black carbon particles. These particles include tiny nanoparticles, smaller than 1 micrometer, 1 micron. Soot and other particles from diesel engines worsen the particulate matter pollution in the air and are harmful to health. By capturing these particles, the DPF helps reduce emissions and ensures cleaner air. Now let's get into the nitty-gritty. How does a DPF work? Picture this. As the exhaust gases pass through the DPF, the soot particles are trapped in the filter material. Over time, these particles accumulate and the filter needs to be cleaned to maintain efficiency. This cleaning process is known as regeneration. There are two main types of regeneration. Passive regeneration happens naturally when the exhaust temperature is high enough to burn off the soot particles. This is common during highway driving where the engine runs at higher temperatures. Then there's active regeneration. When the exhaust temperature isn't sufficient, the vehicle's engine management system kicks in, injecting extra fuel to raise the exhaust temperature and burn off the accumulated soot. Next up, let's talk about the different types of diesel particulate filters. First, we have cordierite wall flow filters. These are known for their excellent filtration efficiency and cost-effectiveness, but they have a lower melting point, making them susceptible to damage at high temperatures. Then there are silicon carbide wall flow filters. These filters have a higher melting point and are more thermally durable than cordierite filters. Ceramic fiber filters offer a balance between filtration efficiency and thermal durability, while metal fiber flow-through filters use metal fibers and are designed for applications requiring lower filtration efficiency but higher durability. Choosing the right type depends on the vehicle's application and operating conditions. Regular maintenance of the DPF is crucial. Over time, ash from burned engine oil and fuel additives can accumulate in the filter. If not cleaned, this can increase back pressure, reducing engine efficiency and potentially causing damage. Follow the manufacturer's guidelines for DPF maintenance to ensure optimal performance. And a quick heads up. Some might consider removing or tampering with the DPF to avoid maintenance costs. But remember, this is illegal in many regions and can lead to significant fines. Plus, it results in increased emissions, harming the environment and public health. So keep that DPF in good working order. As emission standards become more stringent, advancements in DPF technology continue to evolve. Researchers are developing filters with improved materials and designs to enhance efficiency and durability. Additionally, alternative emission control technologies such as selective catalytic reduction (SCR) systems are being integrated with DPFs to further reduce pollutants. Diesel particulate filters play a vital role in reducing vehicle emissions, contributing to cleaner air and a healthier environment. By understanding their function and importance, we can appreciate the technology that helps keep our skies clearer. Thank you for joining me on this journey to understand diesel particulate filters. Remember, regular maintenance and responsible driving habits not only extend your vehicle's life, but also protect our planet. Don't forget to subscribe for more informative content. See you next time.